Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay.
Now the question says that you are given a number n, you have to print the first n natural numbers in decreasing order. Okay. Now I can see you have 5 and you are printing 5, 4, 3, 2, 1, right? Now the thing is that if you want to print the first n natural numbers in decreasing order, again, similar task delegation can work. And this is very closely related to that attendance problem that I said. Let's say there are 5 students in the class and you are going to take the help of all the 5 students to do this. What the 5th student can do, the 5th student can print 5 and ask the 4th student to print the rest of the stuff. Then what the 4th student can do, can print 4 and ask the 3rd student to do the rest of the stuff. Then the 3rd student can print 3 and ask the 2nd student to do the rest of the stuff. Then you can print 2 and ask the 1st student to do the rest of the stuff, and then you can print 1. Here you can see everything is done, nothing more is left. That's how you can actually solve this question, right? So let's say that I write a function f of n. And what does this function do? This function prints the first n natural numbers in decreasing order, right? Again, similar stuff. So I try to follow this framework as much as possible, because in recursion, otherwise people start to think that there is always a new question and something like that. But I try to follow this framework to make things as close as possible. Now, what you can see here is that, first of all, the nth student is doing his or her own task and then delegating the task to the n-1th student. So what I can do is that, if let's say, if somebody asks me to print the first 100 natural.
So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different. And a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video.
Numbers. I can't print the 100 natural numbers, right? It's too much. But what I can do is, I can maybe print the value 100, or you can say print the value n. And then I can ask someone else to print the remaining 99 natural numbers. So what we are going to do is, we are going to assume f of n minus 1 works correctly. That means it prints the first n minus 1 natural numbers in decreasing order, right? If this function works correctly and prints the n minus 1 natural number in decreasing order, n is greater than n minus 1. So you have to print n before all of this is going to be done, right? Before everything around n minus 1 and remaining numbers are going to be done, you need to print n before that. Hence you put the value before this. And now if you see, this is a kind of problem where before delegating the task, you have done everything. You do not depend on the response of the delegation. If you do not depend on the response of the delegation can be void, right? And you can see the same thing I'm going to write. It's a print function, so you don't need any return type. I'll make this void, and you will see I'll write everything like this. Now, the base case, if the value of n is 0, 0 is not a natural number, right? You don't need to do anything, you return. 0 is not a natural number, you don't even need to do anything. Okay. So I'll make a new file, print increasing .java. Okay, I'll say public static void f. Again, same f name, right? I always use this name. What is the argument of the function f? N. That's the only value you care about. What's the base case? If n is 0, you return. That's it. Do nothing, as 0 is not a natural number. Okay. Otherwise, what do? You print n. So how do you print it in Java? You print n and you delegate the task to the n minus 1. You assume that n minus 1 will be done automatically. Let's call for f of 5. It's a void method, so you don't need to do a sysO here. If you run it, 5, 4, 3, 2, 1 just works like a charm. If you do for 50, no problem at all. See, similar stuff, right? So you can see pretty easily, same architecture, whatever I write, I wrote the same thing in the code is working here as well. All of this is working and everything works well. Now let's see if somebody asks you to print it in increasing order. Just think about it. If you have to print it in increasing order, you have been given the value of n as 5. Now what the fifth student will say? Fifth student will say that I can go and print my value, but I cannot just print at the last, right? What I want is, I want first all the remaining n minus 1 students to mark their attendance, and then only I can mark my attendance. So here, the fifth student is dependent on the delegation of the other students, that whatever it delegated to the other students, those students have to complete it, their task, and then only fifth student can do it. So what fifth student will say that? Fifth student will say, hey, student number 4, please mark your attendance, then only I can mark my attendance. Fourth will say, hey, third student, please mark your attendance, then only I can mark my attendance. Third will say, hey, second, please mark your attendance, then only I can mark my attendance. first will say, hey, 0th student, can you mark your attendance? Then only I can mark my attendance. There is no 0th student. So task comes to first. First will mark its attendance, goes to 2. Now 2 can see that whatever task 2 delegated to 1 is done. Now it's the time to 2 to do the task. 2 will mark its own attendance. Then goes back to 3. Right? You can see this was when we were growing in recursion. Now we are coming back. It's like we are coming back from the call stack. Now we are at f of 3. F of 3 sees that, okay, both the students have marked their attendance. Now I can mark my attendance and go back. Then the 4th student sees that all the 3 students have marked their attendance. I can now mark my attendance. And then you come back to f of 5. And now what f of 5 wanted, that before you f of 5 marks its own attendance, remaining everyone should have marked their attendance. They are done. Now you print f of 5. That means if you write a function f of n that prints n natural numbers in increasing order, then here, what do we want? I cannot just print my value. What I first of all want is that, hey, all the n minus 1 students, please mark your attendance or please print yourself. Once you have printed yourself, then I can print myself. Then I will do my self work. So this is your assumption. This is your self work, right? And you can see just by changing the order, you are able to do it. So whenever your self work is after the assumption call, that means you are somehow dependent on the assumption. Okay. So I can make a new file, print decreasing, sorry, increasing this time, right? Oh, I made different file names. Oh, my bad. First of all, let's change this file name. This should be print decreasing. Okay. Here you go. And then I can make a new file, print increasing Java. Okay, same thing. I'll put main here. I'll say public static void f int n. You can see this function takes only a value n. Base case, if n is 0, you don't need to do anything, you return. Otherwise, first of all, you ask remaining people to do their attendance. So f of n minus 1 you will call, right? And then you will print yourself. That's it. You call f of 5 here. Run it. Works like a charm, right? So now I want you guys to do a task. Try to do the dry run of print increasing and print decreasing so that you get the idea, although works in a pretty similar way, right? You just have to go put a debug pointer here, click on debug, right? If you're using some other ID, please Google it how to do it in that other ID, right? And then if you go inside this, you can see, is the value of 5 equals to 0? No. So what do? You call for f of 4. Is the value of 4 equals to 0? No. What do? You call for f of 3. Is the value of 3 equals to 0? No. You call for f of 2. Then you call for f of 1. Then you call for f of 0. The moment you call for f of 0, you can see all of these functions are waiting. You go back and start printing 1. You can see 1 got printed. Then you start printing 2, 3, 4, and 5. Right. So try to do the dry run by your own hand on a pen and a paper maybe. That will be really beneficial for you. But always I believe that after some classes of recursion, you should not try to do too much dry run of recursion. Let's say if you have solved, let's say 10-15 problems of recursion and you have solved and you have did dry run of all of them, then try to always think in terms of mathematics and recurrence, because let's say if in an interview somebody asks you, you might not get too much time to validate your approach with a dry run and then write it. You have to first write it, and then if the interviewer asks you to dry run, then you have to do the dry run. So for that, your intuitive thinking skills should be really good. That's we will try to practice on. But I believe the overall the concept that we discussed today is clear to everyone.